Alright, so I got my new Maxwell 3000 farad capacitors, and they're all in series. And after the issues that I had with the green cap capacitors, I decided the first thing I do is actually measure how much capacitance this bank has. According to the spec sheets, each one of these capacitors should be over 3000 farads, so it should be a minimum of 500 farads for the entire bank with them all in series. To do this, I'm going to take and record the voltage at the capacitors as I charge them. I'm going to charge them with a constant 1 amp current, and then I should be able to calculate the amount of energy that goes into them and see if they are the correct size or not. So I'm going to start logging with the meter, and I'm going to connect power. You can see we're at 0.22 volts. So it's going to start charging it at 1 amp constant current. I'm probably going to wait until it gets up to about 5 volts. And we're going to calculate the theoretical capacitance compared to what I actually get. Now I'm actually going to shut this off at a little over 3 volts, and I'm going to look at the charge time between 1 volt and 3 volts so that I can basically discard the fact that it had almost a quarter volt when I started. But all we're going to do is stop and save our data and stop charging the capacitors. Okay, so we're going to solve for the capacitance in the capacitor bank is what we're looking for. And to do this, I'm going to take the equation which tells us the joules of energy stored in a capacitor in relationship to its capacitance, here C, and voltage V. So I'm going to evaluate this from 3 volts to 1 volt while the bank was charging. And I was charging at a constant current of 1 amp. This means that all the voltage measurements that I'm taking can be directly converted into watts, because it's going to just be 1 times the voltage is equal to watts. So from 3 volts to 1 volt, I want to see how much energy needs to be put into this in relation to the capacitance. So the energy is going to be equal to 1/2 the capacitance times 3, because that's our voltage, squared, minus 1/2 the capacitance times 1 volt squared. So now that we have this formula, we have 2 unknowns in one equation. So that was what the testing earlier was about, is we were actually taking and finding out the energy that we're going to be putting into this. So if we go to the data that I took, we can see that I start out at 0 for a time at 1 volt, and I basically took the data from that time forward up to when it hits 3 volts, and it took 797 seconds to do this. So this graph is showing volts versus time when I measured it off the meter. But because I was saying earlier I was running this at a constant 1 amp, basically it can convert directly to watts. So what we have here is the watts versus time. If we want to take the watts versus time in order to find the joules of energy, we need to find the area under the curve here, and we do that by integrating. So the first thing I did is took and got a best fit equation here for all of my data points. Once I have the equation, I have the same equation here, I integrate it with respect to time. That gives us this equation right here. And what we need to do is evaluate that between 0 and 797 seconds and see how much energy was put into the system. So basically we put in 797 for our time and then subtract off and put 0 in for our time. So 0 times anything is just 0. The final equation to find the energy comes out to be this. Solving for that, we get 1601 joules of energy that was put into the capacitor bank in that 797 seconds. Since we know in this original equation now, we know this energy value. It's 1601. All we have to do is take and put that in and then solve for our C. When we solve for C, we get 400.25 farads is what the capacitor bank measures out to be. Now this is 100 farads less than what it's advertised as. But before I jump the gun and say that there's an issue with these parts, I need to go through and rerun this whole test and double check all of my calculations. If anyone finds an error in the way I'm doing this and wants to point it out, that'd be great. And I also need to look at the data sheets to see how much of a tolerance these Maxwell capacitors allow. And that could be the whole reason that I'm getting less capacitance than what I'm expecting. Hopefully you found this interesting, and thank you very much for watching.